So now let's talk about two interesting components which is new in Houdini 18 is flames and sparse. Let's begin with flames. Let's create again some kind of our source, a sphere, or we can go to our file 1. I even don't know. Let's go to our file 1. Okay, let's just select file version 1. So this what we did when we create the file. Let's save as and choose the flames. So I'm gonna use the same geometry, the same setup, just to show you how we can create the flames using the new system. So as you remember, we use pyro source to create a fuel and temperature attribute, which will then convert using the volume rasterized attributes into the fields. So we have two different fields, it's fuel and temperature. And you already know what is combustion mode. We already know this. Okay, we use our fuel, we create an ignition, and so on and so forth. And now I will delete mostly all of this stuff. I just will leave my fuel source. And what I want to do here, I add a new pyro solver sparse. Connect to output and new smoke object sparse and connect to the first input. But now with new pyro solver, you can see that there is just 4 inputs except of 5. And now we have not the last input. It's not a source. Source now is the third input. So we can apply here some forces if you want to. So now when we apply our smoke object and our fuel source and press play, there is nothing happen and we have some errors. Let's see, what do we have? The error cooking stuff, fuel. Oh, I think that I remove my all smoke object and my link from the voxel size is loose. So now it's creating an error because this voxel size doesn't work. So delete channels and paste relative reference again to make a new connection between our smoke object and the source. Now it's working. But again, if you press play, there is no simulation. You can say, okay, maybe we out of our logs. So my container is not inside of my logs or something like this. Just hide my fire input, turn on the logs, but no, my container inside of this log. And yeah, now inside of your smoke object, you can see that there's no container settings. We have just maximum size, but there is no container. We have the same visualization with domain, multi-field, density, and etc, 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 but there is no our container setup. The reason for that, because this container is adapting without even gas resize fluid dynamic. And I want to show you how to work with that. But before this, let's see why it doesn't work. If we go to our pyrosolver sparse, we have some new settings here. Some of those we already have or we already had in our pyrosolver, like time scale, temperature diffusion, cooling rate, viscosity, buoyancy. You can see time scale, viscosity, temperature diffusion, cooling rate, buoyancy scale, but now it's scale, not just buoyancy lift. But we have something new like advection reflection, we have an ambient temperature and reference temperature, and what's more important, we have the flames. We have flames, which is now a new field created with the simulation. So now we can see the fuel, and the temperature. But fuel is not what we expected in this simulation. We expected field flames. If you go to Advanced tab, we can see some OpenCL setup, and we have something like a sparse CT. And this very important thing to create an active zone inside of our container. But before we do this, we need to define what fields we need to have to create a fire. And inside of resizing tab, we can see that reference fields now density and some mystic field called flame. So how you remember, if we create the gas resize fluid dynamic node, we have a density like a reference field. So this is like main field we look on to create container around this field. But now we have and the density and the flame. So now the flame field is the main field for our fire. It actually creates flame field except of our fuel, burn, and the heat field. So here I want to add a flame field as a target field. So we use the fuel to set this information into the flame field. So in some presets here, we can see that the source volume created not by the fuel, by the burn field. So it doesn't have too many influence. So we can switch from the fuel to like a burn field. We just need to change all the names here from the fuel to burn. But anyway, even if we have a fuel field here, okay, again here too, it doesn't matter what name we have here, we send this field into the field called flame. If you press play now, you can see that we have some container around, but we again don't see anything. And the reason is like we had in first simulation when we talk about pyro, because of some visualization setting. And we look on a density by default, but there is no density. Okay, there is no density. By default, we won't create any density field. We can see here on information, we have a temperature, pressure, flame, the active field, which is very important. We're going to talk about this a little bit. And we don't have a density. So by default, the smoke is disabled on the simulation because mainly I want to create the flames, not a smoke. So there is no density field. So except of this, I go to smoke object, disable density, and enable my multi-field. In a setting here, we can delete density scale. So if you have a smoke or density field, you should apply the density here like we did in our last lesson. And now I will enable the emission scale, but now my emissions field will be the flame and my emission color field will be temperature. All right, so our voxel size is a little bit bigger than I want. So let's back here and put like 0.025. And you can see that our container resizing by default without any gas resize fluid dynamic. And we have some kind of nice fire without any additional settings for now. It's a little bit long, I guess, so we can play with the settings a little bit later. But now what we have inside of our simulation is our flame field. Okay, so this is a new version to create flames without the heat, the burn, flow fuel, etc. So now let's go to my setup here and quickly let's look on our smoke object sparse. If you want to use a sparse mode, you need to enable this sparse solving inside of smoke object and inside of your pyro solver in advanced tab sparsity. Here you can see this checkbox if you want to use it. And now in a few words, what is the sparse mode? If you go to smoke object again, and in visualization, I want to enable active region. And now you can see, let's make it a little bit brighter, I guess, to better view on the background. You can see that we use just some voxels inside of this container and avoid using some unuseful volumes. So in default pyro solver, we use a density mode. So this density mode allows us to resize our container and it's create like a bounding box. So it's just a bounding box. When we use the sparse mode, we can control how many voxels inside of this container will be inside of active region. And inside of these active regions, we will create a simulation. All other voxels inside of our container, which have an active region 0, they will not be included in simulation and they will not be sent into the RAM, which is more important And now we can define the areas where we want to build our container and save a lot of space to avoid, using a very big empty spaces inside of your container. So when you have a moving object, like, I don't know, some like part of the debris or a huge part from destruction, or like missiles or something like that, and they moving non-linear, they'll create like arcs, some curves, and when we create a smoke around this moving object, our container will be very big, and a lot of space inside of this container will be empty because there's no information. Now the sparse mode allows us to define the areas where we have some information, and as in always we will use the resizing tool. So we define the areas where we have a density or the flame information. In our case we have a flame. We have some padding, so it's like a gap between our last information and the active zone, because in many cases we can have like influence from our surrounding volumes, or we can apply like forces, or for some shape stuff we need to apply velocities around our simulation. So we need to have like a gap between our end of active zone and our simulation, have some volume. So we have a padding, it's 0.3 for now, and this means that we have some volumes around my simulation, but we still, even in this simulation, have some zones where we don't have any kind of information, and we will avoid putting these zones or those volumes inside of your RAM. So our simulation will be much and much faster. So we will see this in our building, but for now, what we can see here, so let's set up a little bit of our Pyro solver. So inside of our smoke object, what we have new? Well, we don't have a container size because our container will have the size of depending on our source. So now it's just looking on our information, find this information in our scene and create container around this. So voxel size is going to be the same, but we have the boundary condition. So if we want to thread y-axis or z-axis, we can do this. We can close below or above. And we have a guides. So guides mainly is the same, except of the domain in active region, but all those guys the same. Yes, now we don't have a burn, we don't have a fuel, we have just a flame. So mainly if we use flame, the same fire like we did from like we had from the heat field. All other stuff like temperature, velocity, divergence, pressure, it should be the same like in the density field. We don't have it again, but we can have it if you want to. So now inside of this, what we can do, we have different kind of operations, and sometimes again on the presets you can find that we can use the pull operation for the temperature to create a little bit more realistic result for transferring our information from the temperature field to the target temperature field here. So we can pull our temperature with some acceleration. We have the deceleration and acceleration strengths. So maybe like 25, 20, 50, depending on your simulation you can use here. And again, sometimes you can find that we can set up the maximum operation inside of your burn into flame or fuel into flame transforming. So let's go here again and play this sim. So now you can see is a little bit different. So now my flame is not moving such fast like it was last time. And again, it's looking like flame already, like a fire from my logs. But again, this flame is a little bit longer than I expect. So if you go to our Pyro solver, what we can change here, go to the flames option, and we have the flame lifespan. So we don't have such parameter for the heat. We don't have a lifespan because not only the heat was the only field for creating a fire. We have a different fields which is going from one to another. So, but now we have only one field flame for our fire. So we can use like a lifespan, and this parameter in seconds it takes to use up a value of 1 in the flame field. So if we decrease this number like 1 and press simulation again, we will see that our flames will be much smaller. So actually, how long our flame will exist. Let me make it a little bit smaller again, like 0.6 maybe. Yeah, it's looking pretty interesting. Now we have a nice gradient. It's pretty low res again, but we can work with that. And yeah, our shape is pretty smooth and straight now. I want to change it, but before I do this, let's go to simulation. We have something new here. So except you already knew some parameters like cooling rate or other stuff, we have something new like convection reflection. We can read here what it is, attempt to inject energy loss due to pressure projection back into the simulation. Enable this option, make exhibit better vortex retainment in the flow. So I want to enable this like a single project. I'm going to use this reflection amount by default, like here. And what I want to do, I want to decrease the cooling rate. So 0.5, maybe a little bit less, like 0.4 maybe. And with an ambient and reference temperature, so the ambient is like a surrounding temperature. Okay, so corresponding to what of one is temperature field, this represents the ambient temperature of the environment. And this temperature range is used to calculate strength of the buoyancy force. Okay, so we have the reference temperature for the buoyancy force, and we have the buoyancy scale. It's like a multiplicator for our buoyancy, and we have a gravity. So basically gravity like an always 9.8 and -1 for the y-axis. And now, like, if I want to increase this reference temperature, so let's just make a few simulations to compare different results. So let's just, I don't know, make like 72 frames, and I want to make a play blast or flipbook. Doesn't matter how you call it. I just want to look on a dynamic and a speed and a lens, all this stuff. So this is with the basic, with the default temperature reference 600. If we will write this, you will see some changing. Let's play. All right. You can see some lines here, like layers. This is all because of the sub-steps. By default, they're just one sub-step per frame, so we will increase it a little bit later. Let's look on our real-time simulation. That's how it's looking. And now let's make it 5 times bigger, so 3000. And let's see, what do we have now? Now we can see a difference. We have a much bigger speed because of the bigger temperature, a way bigger speed. The higher flame, because the flame exists at the same time, but for this time it's going a bigger distance. Okay, so now if you compare those results, that's how our temperature applied or have an influence on our simulation. So this is our default simulation, default temperature, and this is our higher temperature for now. So this fire is pretty slow. Yeah, if we look on the same scale, it's like a fire logs, and this fire is very slow, not like in real life. And this fire is something more correct. But again, I can apply, if I want to, I can apply my buoyancy scale. So I can reduce this buoyancy to like 0.5. It will have the same temperature. So many processes which will having influence from the temperature will be the same, but our buoyancy will be a little bit smaller. So now rising speed is a little bit slower for now for us. It's looking good, maybe just a little bit slower, even more. Yeah, should be nice, but like point, I don't know, maybe 0.4 should be fine. Okay, so with the flames, what we can do here, there's a smoke tab, temperature, and expansion. So if you want to add some additional elements like those, you can enable them. And for example, if you want to emit smoke from a fire, you can enable this checkbox, and we have the emission amount. And this amount of smoke we will create from the fire, so a little bit similar like we had a smoke amount from the heat field in our old pyro solver. And we have the flame range, so we define the range of our field where we will get the smoke from this field. So the range of area, the flame field that will generate an output. So by default is from 0.2 to 0.5. In this case, you can change it depending on simulation. So I don't want any smoke in this particular case. And with the shape, we can see that we have some difference between the old pyro because, well, we have a dissipation, which is mainly again work with the smoke. But in this case, I don't have a smoke, so I can just disable that. But we have just 3 parameters left: disturbance, shredding, turbulence. Okay, so we had go to our pyro solver, the old pyro solver. We had a sharpening, we have the confinement, there is no such shapes anymore here, some disturbance, shredding, and the turbulence. So I disabled dissipation because I don't want to use this, I don't have a smoke. Let's enable those guys. You already know how they work. So I can leave disturbance as it is, but by default, disturbance have an influence just on density. That was most important. I want, as you remember, by default, our disturbance applied to velocity in the old pyro solver, but now we have influence on density. I don't want to do this. I want to have an influence on the flame field. All right, and we have a 2 modes, continuous and a block based. I guess I want to use a continuous. Well, I leave it by default. With the shredding, let's see the difference. Turbulence may be a little bit low for now. Maybe I will increase it. 0.1 sometimes could be a very small. Now you can see that our shredding, it doesn't work such good as it works in the old pyro solver, because with the default shredding 0.5 in old pyro solver, it creates a pretty intense result. Sometimes we can even reduce the shredding because if our flames is going from other sides, create like a very, very intense fire dance. Okay, so turbulence, let's just make like 0.2 to have a little bit big influence. Our shape is still pretty I don't know, like a very soft, very straight. And with the swirl size, maybe like 2 to make it a little bit bigger, our swirls. And go to the shredding. So now our shredding again is by default will be applied to our flame field, which is fine, that's what I want to. And I want to increase this influence much bigger, like 10 times bigger to 5, except of the 0.5. And now we can see that our shredding works a little bit better. We can see how it's applied to our fire. It's making our fire more realistic. Nice, not less looking like a wispy. It's more like a real flame. Okay, and those settings is looking like similar to the noise, because we have the roughness, we have the maximum octaves. So I want to increase the roughness, I want to increase the maximum octaves to like 4 maybe, or 5. And well, maybe decrease the block size a bit, like 0.15, and the pulse lanes maybe a little bit smaller to create more, add more speed to my texture or to my noise. So let's apply a flipbook. And even I think that we should add even more shading. Even more, yeah, let's stop it. Let's add like 10 again, and more shading to our file. Now it should work a little bit better. It's a little bit confusing on the start, but later on we can see that it works a little bit better. And again, this is pretty low res theme. We have a 0.01 voxel, but you remember that it's not a very high scale simulation. So I just want to work with dynamic, and then I will work with shading and other stuff with the final input. Well, now this file is looking much better. Much better, I think. Okay. So let's just a final stretch. Maybe 13 should be fine. And in advanced tab, what's more important here is our substeps. So substeps, I definitely increase like 3. It's for the large scale simulation, for the objects. If you have some object for iteration, I can even increase the number of substeps. In this case, this is all what I want to change here on my advanced tab. So let's go to input. Oh, just remove my old one, pyro, and the file input. Yeah. And go to change it into the flame version 1. And here on my DOP import field, except of the heat, I'm going to use the flame field. You will see that we have this field. Let me just go to the next frame. Just a few frames here. Yeah. We have the velocity, temperature, and the flame. We don't have a density, and actually we don't need to have this density. So let's, I guess, increase the number of voxels, and I want to launch my caching. So 0.25 I have, so maybe, yeah, 0.1 should be fine. If you look on our information, I want to set into other frame, just in frame like 5. I just want to see an amount of voxels in my main container. And then we will compare the results. So now I can see my main container, and there is 8 million voxels. Not too many, but anyway, if you go to our smoke sparse and enable the active region, you can see that we have a lot of empty space here, which we don't want to use, don't want to send into RAM in processing. So that's fine, it all works. And let's go and save this simulation into the new file cache, and we will see how we can visualize our sim and how we can render the thing out.